Okay, so here we are. We are going to talk about today in this lesson. We're going to talk about two different things. We're going to go back and talk about pass by reference versus pass by value. I realized at the end of the last time we talked about this, it was a little rushed at the end of the class, and I didn't get to finish fully the concept, so I just wanted to go over that one more time, make sure you understand that important concept. And so pass by value, pass by reference is the first thing we're going to look at. And then the second thing we're going to look at in this lesson is 5.4, method overloading, which is not a long one. It's kind of an easy concept. We kind of talked about it a little bit already. So let's get started with this. So simple example here. So ignore the code up here just for now. We're in the interactions panel of JGrasp here. And I'm going to create some variables. And so remember we talked about the difference between primitive data types and non-primitive data types. So integers, what else are primitives? Ints are primitives. Name some other primitives. Boolean. Double. What else? Short, long, char, byte. What about string? No, string is not primitive. Okay, strings are not primitive. Okay, now we don't exactly know what primitives are compared to non-primitives because we haven't really gotten to our objects unit yet, which will make it clearer. But think of primitives like, it's primitive means basic, right? Primitives like primitive humans back in the time. Let's make a primitive data type called x, give it the value of 3. Right, so now I can drag x out to my canvas. You can see it's got the value of 3. Let's make that a little bit bigger. Let's see if I can. Oh no, my thing is not showing here. My canvas is not showing on this screen. Okay, that's okay. So anyway, x got the value of 3. And then I'm going to make y the value of x. So now, here, we used to read this as y gets x. This is assignment, right? We're assigning x into y. So, y gets the value of 3 as well. So they both have the value of 3. So x is 3, y is 3. Now, if I change y to 15, does that change x? Okay, so you can watch up here, or you can see the values over here. And if I press enter here, you can see that y changes to 15, but x does not change because this made a copy. And that's how primitives work. A copy was made here. So we copied x into y, and then you change the copy. It does not change the original. Just like if you think of twins, like brothers and sisters. I know we have a couple of twins in the class. Not in the class, but we have some twin pairings, and if something happens to one of the twins, it doesn't affect the other twin exactly like the same way, right? Ryan? If I change x now till 7, it does not change y. No. So they're completely separate. Once the copy has been made, the copy has been made, and then that's it. They can go their own paths and live their own lives. Like twins, like real twins. Okay. Now, non-primitives. Arrays are non-primitives. So let's give an example of an array. So let's call this array A for lack of a better thing. And then we'll just go 1, 2, 3. So we'll make this array A. And I'll drag this out a little further because in the video you can't see the canvas. So you can't really see it there either. But we can print A like that. So we can see A has 1, 2, 3. Now I'm going to make another array B, and I'm going to assign it A. So I'm going to assign A into B. Now, if we look at A and B, they are both the same. So I can go system.out. I'm just doing this right now because in the video you can't see the canvas. We can see the canvas. So arrays dot toString of A, and of course it's going to make me import java.util.arrays. Okay, so I've got that in there. And now I can press enter, and I can print out B, and we get the same thing. Now I'm going to take array A at say 0. What's at position 0? It's 1, right? So 1 is at position 0. Let me change it to 3. Let me change it to 7,000 just for fun. Okay. Now, before I do that, let me drag B out to the canvas so you can see it in the canvas. If you're in the video, don't worry, I'll print them out for you. And you can see that both A and B change. Right? So if I print out system.out.println B, it also changed. A, it also changed. Both of them changed the value. Even though I only changed A here, both arrays changed. Because there's really, like when we look at it in the canvas, it looks like A and B are at 2 different arrays. But if we were to do this in the Java visualizer, you would see a better diagram. A better diagram than one is provided in there. So let's go to the Java visualizer and let's make our 2 arrays. Make this bigger. Window capture. So if you wanted to actually make a copy of the array rather than just having these 2 things point at the same array, you would make a new array that the same size, use a for loop to copy all the values over manually. The reason why you have to do it manually and it doesn't do it automatically is to save memory, right? Because if every time we did an assignment using arrays, it copied the entire array, that would be a lot of regeneration of arrays and usage of memory, right? So that's why for non-primitives, it doesn't automatically make copies. Make sense? So if you did want to make a copy and then have them have their own lives afterwards, like integers, you'd have to do it manually with a for loop. Okay, so let's go back to now involving methods in this, because that's why it came up. So this first example, here we were swapping 2 integers. It was a void method, which we then realized this is a mistake, right? We're not actually going to swap these. So if I were to call this method swap and send in 2 values into A and B, these local variables A and B would get swapped. But since it doesn't return anything, it does not affect the values that are used. So if I were to call swap down here in my main method and say swap, let's say x comma y, and I made x and y 2 integer variables. So I said int x is equal to 3 and int y is equal to 4, and I called x and y. 3 and 4 would go in here as A and B. The A and B would get swapped, but it doesn't return anything. And so back here, x and y are not affected at all. X would remain 3, y would remain 4. They wouldn't get, even afterwards, they wouldn't get swapped because copies of these were made. So A is made a copy because it's primitive. B is made as a copy because it's primitive. And that's how that works. Question? I can't see that. Is that Josh? Yeah. So strings are a tricky one because they are also passed by reference. So pointer values, if you were to affect the string. However, if you assign a string a new value, it does replace. It would happen. It would treat. Let's look at the strings one specifically because that one is an interesting one. So if you were to take the string and let's say change one of the characters. Let's say the string was Josh, and you were to change one of the characters in Josh. Let's say you change the O to something else in the method. Then it would affect the original. But if you were to reassign it, right, it wouldn't affect the original because it was making a new string automatically. And there's a reason for that. So we can look at the string one. That's a little bit more of a complex case because it is non-primitive, but sometimes it acts like a primitive. So it's a little bit of a strange case. So we'll look at that one shortly. So the swap here with the two integers, it does not affect the x and the y because copies are made. Then we saw this other example where we made a string array, which is non-primitive. We put Queen and Percy in it. Before swapping, we printed it out, and we get Queen and Percy. Then we call this swap method, also called swap, but it's this swap method. Right? This one takes a string array. Now, because it's non-primitive, and that has nothing to do with the fact that it's a string array. Any array is non-primitive, so it was an integer array, same thing. But let's say we take the string array here. Now, this is just a pointer pointing at this original array names. So if I swap these values here, even though it's void, I change something in this array here, it also changes something in this array. And so they do end up swapping. So if I were to run that, you will see that they get swapped. So before swapping, Queen Percy. After swapping, Percy Queen. So they do end up swapping, even though it doesn't return a new array. We modify the array because it's on the left-hand side of the assignment. We're putting new values in there, and so it does change in the original as well because the copy was not made. Make sense? Any questions about that? Do you want to see the example with a string? Or do you want to try it yourselves? Hands up if you want to see an example with the string. String method. Oh, quite a few hands. Okay, so you want to see a string example. All right. I'm not even sure of this one myself. I think I am. So let's comment this all out. And we'll make a string method to modify our string. Okay, so let's just call it public static. We'll make it void. And we'll just say change string. All right, so we'll take a string, not a string array, just a string, and let's call it name. So we're going to take a string that has a name in it, and let's say name. What's the method again? Replace. I can't remember what it's called. Who can find it? String Java string replace. Yeah, I think it's just replace. Replace. Yeah, so name dot replace. And let's put A with B. So we're going to change all the A's with B's. Now, I'll show you in the interactions panel without using a method. How does this work? We should test it out. So let's go hello dot replace, and then we'll put single characters in here so we can say L, replace the L with K. So this is how the replace method works. Let's press enter, and it didn't print anything out because I put a semicolon there. Remember, in the interactions panel, if you wanted to print it out, leave the semicolon off. So we get hecko. Okay, so replace the L with the K in the string hello. You can put the string, I just put a string literal here, or you can put a variable there, the variable name. So here I'm using the variable name rather than a string literal. Okay, these are considered to be literals, right? When it's just the actual values. Okay, so let's go now into the main method, and let's create a string. So I'll go string. Of course, I've got to make something with an A in it, otherwise it won't work. So string word equals, and let's just say apple. It's got to be case matching too. Apple A, just for fun. So that's our string, and then we will print it out. So system.println before swapping colon plus word. Then we can go let's call our method. What was our method called? Change string. So we'll call change string. It's a void method, so I don't need to put anything on the left-hand side. And I can put in here word. Now let's print out after swapping. And it's always good, like, so the kind of experimentation that I'm doing, and remember, I'm not even 100% sure how this experiment's going to go. I think I know the answer. But it's always good to try these kind of experiments out yourself. Challenge yourself to, if you're curious, don't do the easy thing necessarily, which is just ask Mr. Cardoso or Googling it or whatever. Try it out. Like, you can try this out and see. And that way, it'll last longer in your learning, because if you experimented and you learned it and you figured it out yourself, you'll remember it forever. If you just read it somewhere, or I tell you, or your friend tells you, you don't remember it as readily as something you've discovered. Discovery learning is always the best. So let's try that out. Okay, so it did not change. I thought it was going to change. Okay, so that's an interesting experiment. So that's our word before swapping. Let's make sure we did everything right. Change string word. So we sent word into here. It replaced A and B, A with B. So we had two apples. Printed it after. It didn't replace it, even though it's string. So the weird thing about strings are, so let me show you here. So for example, you can create strings and this explanation will make more sense in the next unit. So I prefer to save this explanation for the next unit. But we can say string, var name, whatever we want to call a string, right? And give it something like this, right? And that actually makes what we call a string object. The long way of actually doing it, and you'll learn this more next year, let's say var name, not next year, sorry, in the next unit, is equal to new string. So this is the actual proper way of declaring a string. And because we use strings so often, they decided to leave out this crazy syntax and just say, okay, you can just do this as a shortcut. But this is what really happens. Now, when you do assignments, let's say we went var name 1 gets var name, like that. So now you're reassigning it, because it's not primitive, because it acts like an array, right? This should just be pointing at this one. This one should just point at this one. So if I were to change now either one of them, both of them should change. However, because of this little shortcut that they say you don't have to do this, because you don't have to do this new string thing, it does actually create a new one every time, and it ends up making a copy. So strings is the one exception to this rule because of the shortcut. And it will make, I know it's confusing right now. The strings thing is confusing right now, but it will make more sense in the next unit why the strings are an exception to a rule, even though they're not primitive. It's only because of that shortcut. And the reason why it's even confusing to me is because Java changed the rules a couple of years ago. I don't know, it was like 4 or 5 years ago. They used to be hard and fast, and then the strings would act like arrays. But it confused so many people who just, because imagine you're coming in grade 11, and you're just learning about these basic Java types. It's already intimidating as it is. You're learning about ints and doubles and declaring things. And you're like, I used to program in Python, and I didn't need to know about all these data types. And so imagine doing that. And if they stuck to the rules that strings were objects, and you had to really declare them that way, learning them right away would be very cumbersome. So then they switched it to make it easier to learn strings, because strings are so readily used right off the bat in programming. And then when they did that, then now it doesn't follow the rules of as closely as other object types like integers. So that got very confusing there with the strings at the end. I apologize for that, but I'll come back and explain the strings a little bit more once we get into the objects unit and what this even means. This new string thing, we've seen that with new scanner. What does that even mean? We're not sure yet. But that's the proper way of doing that. This is the shortcut, and because of the shortcut, it then seems like it doesn't. It seems like a primitive, even though it's not. Does that make sense? So we'll come back and revisit that. Any questions about that? Okay, so that was a little confusing there. Now,